All right, so we got a little taste of right triangle trigonometry, especially when we were looking at the x over the r, the y over the r. But here we can have right triangle trigonometry in the sense of just sides. So if you have a right triangle and you have an angle theta, the thing that's opposite of the angle theta is what we call the opposite side by obvious reasons. The one that's next to the angle theta is what we call the adjacent side, obviously by obvious reasons. And the longest side, which is basically across of the 90-degree angle, is what we call the hypotenuse. So therefore we have the sine, cosine, and tangent. We can go ahead and classify them using these sides that we just have made up on a right triangle. Now a really good way to remember this is Sohcahtoa. So you can think of sine being the opposite over the hypotenuse, the cosine as the adjacent over the hypotenuse, and the tangent as the opposite over the adjacent. Okay, so you can just write it that way. And obviously the secant, cosecant, and cotangent, we don't really memorize these just because if we have sine, cosine, and tangent, then we can figure out the rest of them. So let's go ahead and do this example. So we want to find the values of the 6 trigonometric functions given the following triangle. All right, now notice, be very careful. I made a little switcheroo for you because now alpha, or A in this case, is up on the top, it's not on the bottom. But we can still classify them. Everything across that angle A is going to be the opposite, so this guy is the opposite. The one that's next to the angle would be called the adjacent. And then obviously the one that's left over, which is across the 90-degree angle, is what we call the hypotenuse. So we can just use Pythagorean Theorem here. So to figure out what the C value would be. So C squared equals A squared plus B squared. So we're going to get C squared equals 116. Okay. And we're going to take the square root. Notice that we're only going to take a positive one because it'll just make sense for a triangle to have positive lengths. So this should be 2 square root of 29. All right, so now we want to find all 6 trig functions. So let's go ahead and look at sine theta, or what it will be sine of A. So sine of A would be the opposite over the hypotenuse. Okay, so the opposite is 10 over the hypotenuse is 2 square root of 29. So it's 10 over 2 square root of 29, which is basically 5 over square root of 29. I'll be okay if you just leave it that way. Now we're going to do cosine of A. Cosine of A is the adjacent over the hypotenuse, so it's just the 4 over 2 square root of 29, which is just basically 2 over square root of 29. The tangent of A would be the opposite over the adjacent, which is just a 10 over 4, or 5 over 2. And now all we got to do is just do the reciprocals. So sine, in this case, the reciprocal of sine is cosecant. And we're just going to swap that, square root of 29 over 5. The reciprocal of cosine is just secant. It's going to be square root of 29 over 2. And then the reciprocal of tangent is cotangent, which is going to be 2 over 5. All right. Now, one thing to be very aware of is that you can rationalize these if you guys want. So you can have 5 over square root of 29, and you can rationalize them for sure by multiplying it by the square root of the denominator. So on the top, you'll got 5 square root of 29. And this one, you can kind of think about it as, let's take a little shortcut. You got a square root times another square root. The square roots cancel, so you're just left with a 29 there. Okay, so you can definitely rationalize it if you want. Okay, now let's do this next example. So To find the height of a tree, a person walks to a point 30 feet from the base of the tree. She measures an angle 57 degrees between the line of sight to the top of the tree and the ground. So find the height of the tree. All right. So here we have an application problem. We have a tree. So let's say here's my tree. Label that tree. And you got this person who measures a point 30 feet from the base of the tree. So here's the base of the tree, and I travel over 30 feet. And she measures an angle between the line of sight to the top of the tree and the ground. So between here to the top of the tree is 57 degrees. Okay. And now all we got to do is take or find the height of the tree. So this is what we're looking at for height. So let's go ahead and look at this and kind of think about what trig function would be best to classify this as. Well, notice that from the degree to the thing that we want is the opposite. And then the 30 here is the adjacent side. So it would make sense for us to use tangent. So we're going to use tangent of 57 degrees is equal to the opposite over the opposite over adjacent, which is h over 30. I'm going to multiply by 30 to the other side. So we got that h equals 30 tangent of 57 degrees. All right, now all we got to do is figure this thing out. All right, so let's go ahead and bust out our calculator. So I'm going to bust out my graphing calculator, but you can do it here. One of the things that you have to make sure that you do is that you have to make sure that you're in the correct mode. So if you have the graphing, the TI-36, make sure that you go into your mode and change the radians to degrees. Okay, so for those that have the TI-30, you're going to have to click on mode, and then the first one is going to say degrees radians. Make sure that it's in degrees. Okay. So now we're going to put 30 in here, and then we're going to multiply this by the tangent of 57 degrees. You don't need to put the degree sign, you can just put 57. What you're going to end up getting is about 46.2. And this is in terms of feet. So that's how tall this tree is. All right, so let's go ahead and do this next example. So, from the top of a 100-meter high lighthouse, the angle of depression to a ship in the ocean is 28 degrees. How far is the ship from the base of the lighthouse? One of the things that you have to be very careful with is this guy, the angle of depression. Okay, so if I think about the line of sight of someone, so let's say here is me. An angle of elevation would be from here to here. This is angle of elevation. So kind of like what we had over here. The angle of depression would be from this horizontal line of sight downward. That's the angle of depression. So let's go ahead and try to draw this. So we have here a top lighthouse, right? And it's 100 meters. And the angle of depression from this top all the way to the ship out in the ocean, so ship, is 28 degrees. Now you have to be very careful because what's 28 degrees? So imagine that I'm right here and you got this horizontal line of sight. The angle of depression is going to be this guy, not this bottom part. It's going to be this guy. This guy is 28 degrees, right? And what we're looking at is, so here's the lighthouse again. This is the lighthouse. how far is the ship from the base of the lighthouse? So we're looking for this. Let's just say this is the base. So this forms a 90-degree angle. So we can see here, okay, well, we got this 28 degrees here. Can we possibly figure out what this other guy is, this guy? Well, it's really easy because isn't this whole thing just a 90-degree angle? So we just take 90 minus 28. That gives me 62 degrees. So all we got to do is just use a trig function that will go ahead and represent this side, which is the opposite, and this side, which is the adjacent. So again, this is opposite over adjacent. This is another tangent problem. So it's tangent of 62 degrees is equal to the opposite, which is b over 100. So I'm going to take 100 times the tangent of 62 degrees. So you can put that in your calculator, 100 times tangent of 62. Okay, and I think I'm in the wrong rating. This calculator, I'm in the wrong one. So 100 tangent of 62 degrees, that gives me 188.1. And then this gives us meters. All right. Now, alternative, what you could have done is done another way. So you can just say, oh, well, if this is 28 degrees, this guy should also be 28 degrees. Okay. So you could have also done that too. Or notice that this is 90 degrees. This is 68 degrees. Whole triangle should be 180. So this should be 28. And in this case, you can also use this angle to relate this guy with the other guy. All right. So you still will use tangent, but you're going to be reversing it, and now with the 28 degrees. So it'll still give you exactly the same answer. All right. Now let's go ahead and do this next example. Okay. So maybe pause the video and try it out for yourself. This one's a little more complex, but you can still do it. So from the top of a 20-meter high castle wall, the angle of depression to a knight in the field is 16 degrees. The knight rides directly towards the wall until the angle of depression is 50 degrees. How far did the knight ride? Okay, so that's what we are looking at. So maybe let's go ahead and I'm going to go ahead and try it out. So we have for the top of a 20-meter high castle wall. So let's say this is the castle wall. And it's 20 meters. Okay, the angle of depression. So I'm going to go ahead and put a point here and write a horizontal line. So kind of imagine that's a line of sight. So from the top all the way down to where the angle of depression to a knight in the field is 16 degrees. Okay, so going from here all the way to maybe some other point out here. It's terrible, but whatever. This guy is 16 degrees. Okay, so here's the knight. And now what's going to happen is that the knight rides directly towards the wall until the angle of depression is 50 degrees. So it's going to keep going and stop again. So at this point, I got another angle. So at this point, the angle of depression, now be very careful, it's not this small part, it's this whole thing. This whole thing right here is going to be 50 degrees. Okay, maybe I can just go ahead and close this as well. We want to know how far did the knight ride, which is basically this guy. How far did I go from there to there? Okay, so now that we have this picture, the picture was probably the hardest thing to do. How would you go ahead and figure that out? I guess the challenge of this is that we can't quite use Sohcahtoa anymore. Because if you look at this triangle where I have the unknown x, you can see that this is not a right triangle. So this guy right here, let me just color it in. This guy right here, do this. This whole triangle, this guy is not a right angle. So I can't quite use Sohcahtoa here. I can't. It's just not possible. So instead what I'm going to do is I'm going to do something a little different. So I'm going to pretend that how can I possibly figure this out without knowing how can I, or in other words, how can I use right triangle trigonometry to try to figure that out? Because you can definitely do it with law of sines and cosines, but we're not there yet. So let's look at two different right triangles that we do have. So we do have two right triangles. We got this big one right here. I got this big right triangle right there. I know it doesn't look like it, but it is a right triangle. Let me just get rid of that. So I got this big right triangle, okay, which just forms a 90-degree angle. So notice here that this would give me this distance here, from here to there, from there to there. I'm going to call this D1. And notice that I do see another right triangle inscribed inside of it, okay? So let me just color that. Well, actually, let's start with the red one first. Let's try to figure out what this D1 is, all right? Now, in order for me to do that, so we're looking at the red triangle. Let's first figure out what the angle of the top guy should be. Okay, so that would involve this one right here, this angle. We want to know what exactly this angle is. Well, because I know this is a 90-degree angle, this whole thing is 90 degrees, we already know that this guy is 16. What would the red one be? Well, that would be whatever 90 minus 16 is. Okay. So I'm going to take 90 and I'm going to subtract 16 and I'm going to get 74 degrees. So what this is saying is that this red part is going to be 74 degrees. So I can easily figure out what D1 is because now D1 will be my opposite and then my adjacent will be 20. So I can use tangent. So tangent of 74 degrees is equal to D1 over 20. Multiply 20 over, gives me D1. So D1 is going to be approximately equal to whatever that is, 20 tangent of 74, which gives me 69.7. Okay, so what that tells me is that this distance, this red distance right here, down here, this whole thing is 69.7. All right. And now what I want to look at is, now let me look at this other triangle. This guy right here. Let me color it something different, green. So you can see I have another inscribed right triangle. This guy. All right. So I can use the same thing because now I can find this green distance, which I will call D2. So notice, if I know D1 and then I know D2, I can subtract these two and I can get what this X value is, which is how far the knight traveled. All right, so now let's go ahead and do the same thing. Let's figure out what this green angle is going to be. Now, just like before, I knew that this was 50, and I know the whole thing is 90, so we're going to do 90 minus 50. 90 minus 50, that's going to be 40 degrees. So I'm going to do the same thing. Tangent of 40 degrees is equal to D2 over 20. I'm going to multiply by 20 to both sides. So D2 is going to be approximately equal to, let's put the 20 tangent of 40 degrees. That gives me 16.8. All right, so now that I know what D1 and D2 is, all I got to do is subtract the bigger one and the smaller one. So X is going to be equal to the difference of D1 minus D2, which is 69.7 minus 16.8. So I'm going to subtract these guys, 69.7. minus 16.8, that's going to give me 52.9. Okay, and this is going to be in meters. Right, so this is how far this knight ended up traveling.